Hello, good morning everybody. My name is Kurniatun Hairiah from Universitas Brawijaya, Malang, Indonesia. First of all, I would like to thank to the organizer of the Conference on Agroforestry 2022 for the invitation to share our experience of agroforestry in Indonesia. The topic I would like to share with you, I choose multifunctional landscape, future land use with agroforestry. Under current conditions, we need to adapt to the climate change, which aim to the reversing the trend toward increased human vulnerability. That is itself the result of land degradation, loss of diversity, and climate change. The synergy between mitigation is needed too to address both local and global concerns simultaneously. Therefore, the need for a better environment has increased to anticipate more fluctuating rainfall. Therefore, we need also a healthy soil to support hydrological buffer function and a healthy environment. Three things I would like to discuss here. It is related with the land use issues in the past and at the present condition. The contribution of agroforestry at the tree, land or landscape level. Some case study from Indonesia based on our research results related with the declining in soil fertility and environmental issues, something like carbon and landslides. And the last one, I would like to close with the research still needed related to agroforestry for the future. There are many types of soil which differ one place to another due to different geomorphology and climate. The existence of climate change we have now give an effect its function for the ecosystem, such water availability, nutrients, and soil organic matter, carbon stock, soil biota, plant growth, etc. And of course will affect on the benefits for humans being. Given the benefits for the wider community, it often requires government intervention in managing it according to local conditions, farmer skills, and market demands. Here is Pak Ahmad, the durian agroforestry farmers in Ngantang, near Malang, where we had a collaboration for quite some time, said that farmers mostly posing soil fertility problems, especially for vegetables farmers like in these photos. But not with his durian agroforestry, he will not get that problem because it always get enough organic input. While these vegetables farmers, such cabbages, depends very much on the artificial fertilizers. So now I would like to share with you another example from our research result in Sulawesi related with the soil organic matter mitigation and adaptation to climate change in cocoa-based agroforestry system. There are various cocoa agroforestry system, various age, like 17 till 35-year-old, and agroforestry young cacao about 5 years old compared to the multi-purpose tree species and the multi-purpose with the young monoculture cacao system. And of course, it should be compared to the secondary forest. How is the results? First, we have to understand about the relationship between agroecosystem structure, functions, and benefits for humans in relation to soil, climate change, and especially with water cycle. Trees, either in agroforestry or in the forest, wherever they are, they have a reciprocal relationship between the canopy and roots, between above and below ground. Both contribute to the availability of soil organic matter, which is needed to maintain soil hydrological condition, which is important to buffer rainfall water volatility. as the basis of the strategy to adapt to climate change. This is important for local farmers, of course, but maybe less for other stakeholders. Trees also contribute to the terrestrial carbon production as the basis of climate change mitigation strategies. Which one actually is more important for farmers? Of course, for the first one, but for the second one, for the mitigation strategy, it is important for policy makers. This one is needed as a basis of communication with outside world. How was the result from this study? Let's continue. As part of a climate change mitigation strategy, measurement of soil organic carbon content is very important. The results here shows that in the top soil layers, that is 0 till 10 cm depth, the total sea organic is still very low, less than 2%. Only in the forest, just 2.2%. While in old agroforestry cacao system, is even still lower than that of young cacao agroforestry. This can be explained probably from the fact that young cacao agroforestry just recently or 5 years been converted from secondary forest to the cacao agroforestry. So at present, the organic content of the soil is still better than the old one. I don't know for later how long it would be last in the soil under such condition. So now, let's look at the carbon content in the above ground. The results here are quite different, very different from the trend of carbon stock in the soil. Cacao monoculture here showed the lowest carbon content compared to the one in agroforestry system, while in the soil they do not have much change in the system. But in the agroforestry system, carbon is quite different between the older and the more complex, more biomass carbon is stored, but is still 60% lower than the one in the secondary forest. From the soil, as you could see here, from the four system of agroforestry as well as monoculture did not have much difference. In the forest, there are more in the roots but not in the soil. So this one is quite different in the forest in Sulawesi compared to our forest in Java, because the soil that is from volcanic soil is quite high in the carbon content rather than carbon stored in the biomass. Soil organic matter is important for maintaining soil adaptability to climate change. As you could see here, the two graphs from our measurements showing that the high soil organic matter, that is in the x-axis, followed by increase in soil hydraulic conductivity and the availability of water capacity. This one, the two parameters are very important to support the plant's growth either in the agricultural land or even in the forest. And now we are going to discuss at the landscape level related to the emission versus sequestration of carbon related to the land use change. I would like to share here the case study Bangsri micro watershed in Malang, East Java. One indicator of degraded watershed is normally indicated by high levels of carbon emission resulting from a decrease in forest cover area. Therefore, the analysis of land cover change in the Bangsri micro watershed is carried out according to the history of land use change. So this is the first step of our methods. Decreasing the extent of natural forest to other forms of use is usually followed by increase in carbon dioxide emissions, primarily as a result of the loss of tree biomass in the forest. The first step of our analysis in this watershed, we do the analysis of land cover change was based on the land cover change from 4 different satellite imagery observations was in 1994, 2001, 2011, and 2017. Based on the land use map of 2017, we learned that in the 297 hectare of micro watershed has 8 types of land use systems, with the largest area was about 32% of the total area is smallholder agroforestry, and a very tiny and small production forest 0.1%, mainly this one is mahogany, or also a pine tree belongs to the state-owned land which managed by Perhutani. So for the next measurements from our rapid carbon stock appraisal, followed by measurement of carbon at the plot level. I would like to show here the plots what we had been measured. In the middle part, we focusing on the middle part, that is agroforestry, that is various age and then various type of trees and various density. The second part, in the second layer, that is more open, that is certain one it is still open because it's still quite young, and the other one is in the agroforestry coffee based system, or as well as in the fruit tree based system. The last one is in the lower part is bamboo, based on the bamboo system. This all we measure the 9 land use type and compare it to how much actually carbon has been stored in different land uses. Now we enter on the extrapolation activity of carbon stock from the plot level to landscape level. From the partial analysis, we learned that there is a slight increase in the agroforestry area of a settlement and agricultural land. That is quite a lot. But there also a reduction area of forest. That is not because of the forest conversion, but it's because number of trees died due to the eruption. The second measurement on the right hand side here, that carbon measurement at the plot level, we could see here that carbon stock in old production forest, that is mainly a pine, that is age of more than 40 years old, are almost the same as carbon stock it found in the natural forest, while in the cacao system, either old or young, was about 50 till 60% lower than in natural forest. The lowest carbon stock shown by annual crop system. So how much actually the sequestration or emission of carbon in this area, mainly related to the land use land cover change. By integrating the two data at the plot level and land use land cover change data, we can estimate how much actually carbon has been emitted from that area for period 1, period 2, and period 3. The first one was about 9.5 tons CO2 per hectare per year has been emitted, and period 2 reduced become 2.5, and the last one in the period 3 is about 6.4, back to increase because of a lot of sulfur gas emission from the volcano in that time. So, as a lessons learned from Bangsri, that land use change in the Bangsri watershed in the last 2 decades has reduced the carbon stock in the landscape, with this differs between periods. The first period was about 9.5, the second one was 2.5, and the last one was 6.5 ton CO2 per hectare per year. That one is mainly related to the forest degradation, reduced number of trees in the production forest, or even in the community-owned agroforestry lands, or agroforestry lands has been converted to monoculture annual crops because of the loss of tree biomass that lead to the declining of the carbon stored in the system. In Malang, recently we got a problem on forest fires during dry season. On the slopes of Mount Arjuna, as you could see here, that is quite number of places that is black stuff things, that is the area where trees in the forest been burned because of the long dry period. The forest fire that occurred often during the dry season, as happened in Malang too in 2019. It caused 3 deaths and the loss of the soil anchor function of the tree roots. So, in the following rainy season, the dead tree trunk slide down to clog river paths, forming a new dams in that area. While heavy rains that already come during the rainy season had caused flash floods in the Batu area, especially in the riverbanks areas. A lot of houses are damaged and a lot of agricultural land has covered by the materials from the upper parts of the slopes. So now the question is, can tree roots in agroforestry system reduce shallow landslides? Not all tree roots the same, but then it depends on the root characteristics, root tensile strength, root length density, and root to shoot ratio of tree species. All those study measurements we had already published on a paper in Land entitled Tree Roots Anchoring and Binding Soil, Reducing Landslide Risk in Indonesian Agroforestry. The measurement has been done on 685 trees, consists of 55 species with DBH about 4 until 20 centimeters at the 6 watersheds in Indonesia, mainly in Java. That is on Sumatra, we have in Lampung and Bogor, West Java, and 4 sites in East Java. All are in the mountain area, especially in the coffee agroforestry system. The next roots characteristics that's important as an indicator of a good and strong roots for reducing risk of landslides is the lignin content. With the higher lignin and polyphenolic content, make the roots stronger, it's not easy to break off. This one I show you the how our student in the field in Lampung to measure soil shear strength of various roots quality and root density. The results show that the second measurements of our study in Sumberjaya, that is related with the tree root length density related to the soil shear strength. The result shows that the shear strength of a volume of soil increases proportionally to the number and strength of individual roots. Which tree species is suitable to maintain the stability of the riverbank? We developed 2 index of tree root system. That is, first one is IRA, index of root anchoring. That is the vertical one here in the middle, that is related with the vertical root. The other one is IRB, index of root binding. The function is as a binding the soil that make less erosion. While the other one, it is assessed, vertical one is important as an anchor of the soil. So that make the slope is more stable. Based on the observed index root anchoring or IRA and IRB root binding distribution at the species level, we have 55 species. The lower and upper quartile of roots were varies between species. For IRA is ranging from 0.5 is the lowest one and the highest is 1.8, and 0.5 till 1.5 for IRB. IRB is less than compared to the IRA. Using this threshold, we could see here on the left, that is the schematic distribution of horizontal roots and vertical roots of 55 species, so we do the further classifications of 3 species observed in the survey. So from this one, the differences in the distribution of tree roots between species can be used to reduce landslide risk in the context of productive coffee agroforestry systems. Ladies and gentlemen, this table actually to show you that not all tree root systems are the same, can reduce the risk of landslides. As you could see here, the Hairiah is only a few of 3 species are there. Only on the corner, right corner below here, Miscelia alba, Coffee arabica, Clyricidia sepium, Zena spectabilis, and Coffee canfora varietas robusta, Piper aduncum, and Melena arborea. Those are 3 species which has a potential, it potentially can reduce the shallow landslides. So as a take-home message from this study related with the slope stability, we found that characteristics of tree roots differ between species. Roots needed spread deep, big and strong, mainly rich in lignin, that is for living anchor, and trimming tree branches improves lateral root distribution, and the strong side effect implies that site-specific observation are still needed to select suitable trees for landslide reduction locally. Now, from soil fertility problems, now shifted to more complex environmental problems. The challenge for the future and what sort of research is still needed. Ladies and gentlemen, our landscape has changed, the same as in other places after the pandemic. Change of market needs and demands too. The landscape used to be only focused on food and vegetables production or timber and or cattle just recently. But now has changed. There is also a change in the needs of urban communities, that is beautiful and clean landscapes or even contemporary tourist attractions like what I showed here, which demands change in policies as well. But not only policy, but also skills of rural communities, how to manage their land for ecotourism, which needs more soil diversity as well, especially related with what the tourist demands needs about water, well, a clean and attractive landscapes. Our farmer mentioning that people used to plant corn to harvest the corn cob or seeds for our food, for vegetables, but not now. Corn is just for livestock. Because we have a shortage of fodder, so the economic value as a fodder is more interesting rather than as food. So that's why the market for the maize biomass is more interesting. In the mountain, farmers are interested to have new element, a new component in their agroforestry system is cattle, because huge economic gain. But there is a threat though in the future from the manure and urine waste entering river flow in the rural areas. New research and regulation to help farmers are really needed soon. Ladies and gentlemen, well, from our landscape here in the mountain, there are shifting of farmers' needs that's related with the integration of livestock in agricultural land and the number of trees outside the forest area. It continues to increase, and then there is a shift from food production to various urban demands. And then the last one is a new change of rural-urban links, where livelihoods and skill demands are a challenge for both rural and urban communities. So two policy intervention is needed, is related with the water management inside and outside watershed, and the second one is improvement of development planning. Multidisciplinary research are still needed as related with the decision making by farmers in choosing their livelihoods, usually uses technology to increase food production regardless of the consequences of environmental quality and agricultural product quality. Now, moving to the spatially activities are focused on the gradual transition from rural to urban areas. And temporarily, the pattern of change from a production to multifunctional landscape is part of wider change in people lifestyle, for example, the increasing need for recreation, etc. The multifunctional agroforestry meets many of the needs of the poor, but the knowledge transfer, science, and technology to support it will require a paradigm shift with greater emphasis on one that is related with the integrated approach to land use management that involves a participatory local approach to develop planning and implementation. The second one is use of natural resources wisely and less dependence on inorganic inputs and fossil energy. The third one is maintaining agricultural diversification for soil improvement, pest and disease control, and new marketable products. Wise livestock to support agro-ecosystem health, restoration of degraded land, and reduction of yield gaps is very important too. And the last one is the better integration of agricultural sector, government, departments, and institutions, communities, and stakeholders to overcome disconnects between policy and practices. Okay, that was my presentation, some experiences from mountainous agroforestry systems. I hope you enjoyed. Thank you very much for your kind attention.